I'm Einat Sandbank. I work for Fish and Wildlife Conservation Commission, Fish and Wildlife Research Institute in the Florida Keys, FWC for short. And I'm going to talk about how we monitor queen conch in the Florida Keys. A little background, this very charismatic snail is a queen conch. It's large, as you can tell, and they're long-lived. Snails can't really be aged accurately, but corals growing on live snail shells have been aged to be about 20 years old. Like most marine inverts, they start their life as plankton, but unlike most marine inverts, they require internal fertilization to reproduce. This makes our job a little bit easier to survey them because during the spawning season, they aggregate into big spawning aggregations, which makes it easier to count all the individual animals. They are found in the tropical Western Atlantic, including Bermuda. In the Caribbean, the fishery is estimated to be worth about $70 million. But in Florida, where I work, the fishery has been closed for over 30 years. And in the Florida Keys specifically, where the fishery was centered, the Florida Keys are referred to as the Conch Republic, and people born in the Florida Keys are referred to as conchs. Since the closure of the fishery, the state has been monitoring the recovery. Unfortunately, the recovery took a little bit longer than expected, and the fishery is still closed. From 1993 to 2013, we surveyed just breeding aggregations. Like I said, during reproductive season, the animals aggregate, so it's more effective for us to survey these large aggregations during the spring and summer when they're reproducing. But in the last 10 years, the population has rebounded somewhat, and numbers got so large that these breeding aggregations became very difficult to survey. And in 2013, queen conch were petitioned to be listed as on the endangered species list, and this really drove us to develop a new methodology for how to survey these animals. And in 2014 until now, we're surveying using the new methodology. Our goals in developing the methodology was to improve our keys-wide knowledge. We knew about the aggregations, but other than those specific aggregations, we didn't know much about where they could be. There is a lot of possible habitat they can be found in, and other than those aggregations, we had no idea. We also wanted to develop a method for other people to use on species where little information is available. So our previous knowledge in developing this methodology were the aggregations. We had 40. Each year, we would survey about half of them. And this doesn't look like much for a map, but this is a very zoomed in aggregation map. The purple spots are where queen conch are found, and those were the aggregations that we surveyed. These seem very small over the grand scheme of the entire region because they're only about 1 kilometer wide. But for 2 divers to survey that's very difficult, and so we had to come up with a new surveying methodology. Our new area, we expanded to include the entire back reef in the Florida Keys. Our northern extent was up to Hawk Channel. Hawk Channel is a silty channel dividing the reef and the land, and queen conch are almost never found in that silt because they cannot hop on it. Our southern extent was the 60-foot contour line, and that was because we were expecting to do a lot of scuba diving, and 60 feet makes it a little bit easier and safer for us. We then created over this polygon a fishnet using the fishnet tool, and each cell is 100 meters by 100 meters. This fishnet was further divided geographically according which keys it was most adjacent to. We've got the upper, middle, lower, and Marquesas keys. And then even further divided into probability zones. This is the probability of finding a queen conch in that cell. We had the high probability zone, which is the aggregation. We knew if we went to any one of those cells, we would see queen conch in them. Medium was the area surrounding it to the southern border of our sampling universe, up to 750 meters north of the aggregation. This sounds a little bit arbitrary, but because we had a lot of local knowledge, we talked to a lot of people, and the back reef that was agreed upon where it pretty much ends. Low probability was the area in between our medium and Hawk Channel. And we said that this acted more of a buffer zone. We said that in 1,000 cells that we would survey in low probability, we'd see one of those cells might have a conch. In the medium, it was 1 out of 100 would have a conch. And in the high, is all of them that we'd survey would have conch in them. We decided to survey 250 cells the first year. This was based off of power analysis, as well as our diving capability during the spawning season. These sites were random, but because we have the probability zones, they had to be allocated accordingly. And using tests with simulated queen conch populations using our old data, we developed this allocation scheme where 15% of our sites would be in low probability, 70% would be in medium, and 15% would be in high. We wanted to really concentrate on the medium probability zone because we did not know much about it, and it had possible good habitat for queen conch. And we also made sure to survey 2 cells within each aggregation so that we'd have a better idea of that aggregation that later can be used for trend data. And this is what our field surveys include. We send 2 divers down, drop a weight, 1 diver swims out in the 4 cardinal directions and lays out a 30-meter transect tape. The second diver follows and takes down data, counts conch, the habitat they're in, depth, age classes, and any reproductive activity. After the field season is over, we go back to our original maps, and this is where the adaptable portion comes in. We change the maps according to what we find. We can elevate cells, downgrade them, remove them completely from our sampling universe. The fishnet makes it very easy to adapt our sampling universe according to what we find in the field. And then this is an example of how much the maps have changed in the first year. This is a zoomed in of one area in between the middle and lower keys. You can see we took out the low probability zone. We found out after diving in it that was basically Hawk Channel. That was terrible habitat for queen conch. We do not need to survey that area again. We also elevated a few cells. We found new breeding aggregations, so we changed those cells to be included in the high probability zone. Then we calculate abundance based off of the maps. We calculate throughout keys-wide abundance and also by region and for each probability zone. This is simply done by using the density we find in that probability zone in that region and extrapolating it for the entire keys. This is, I know I just threw a bunch of numbers, but concentrate on the highlighted part. This was our keys-wide abundance for after using the original maps the first year. It's almost 2.5 million conch, not an animal that should be listed, but we didn't believe this was accurate. We had to change the maps a whole lot after the first year, and we thought this was an inflated number, that a lot of our cells were misclassified, and this was not an accurate picture of the Florida Keys queen conch population. This is the new abundance after we adapted the maps. You can see it dropped tenfold. And we were still not very confident in it. You can see the standard error is still very, very high, but it was a more ecologically realistic number for what we were seeing in the field. And so our future work, we've been serving this, it's a little outdated, the results, but we've been doing this survey for 6 years. We hope that our reclassification drops down a whole bunch. Right now, to calculate standard error or deviation, we have to assume that the probability zone is random strata, which makes that error very, very high. We hope once we dropped our reclassification that we can consider it fixed strata, which should make our results a lot more accurate and confident. We are also working on predictive modeling using habitat data. After doing this survey for about 6 years, we can look at a map and guess where we'd see conch. I want to automate that part and make sure our sampling universe is the most effective, the most accurate, using habitat data like biocover, depth, slope, might give us clues of where to find queen conch. This is still very much in the working process, and we are only now starting to work on that. So hopefully I'll have another presentation in the future for how to find queen conch using models. And that's it.